So let's start. So in this session, I will be discussing a very important subtopic in number theory, and that is the Diophantine equations. We all know that International Mathematical Olympiad focuses on 4 topics: number theory, geometry, algebra, and combinatorics. And one of the most important subtopics in number theory is Diophantine equations. So first of all, what is a Diophantine equation? Well, a Diophantine equation is simply any equation, but instead of solving it on the real numbers, we solve it on the integers. So for example, this equation, m times n equals 6, where m and n are integers. This is a Diophantine equation. So we just solve it on the integers because we're dealing in number theory. Okay. Diophantine equations are really important and come a lot in mathematical contests and have several methods in order to solve them. Some methods are the factoring method. So what do we do in factoring, or actually why do we factor, for example, the left-hand side? So for example, if you have an equation and you can write it in this form, m times n equals 6. So now you can just discuss the divisors of 6. Since m divides 6, we have that m is 1, 2, 3, or 6. So if we can factor the left-hand side and the right-hand side, we have an integer, we can simply just discuss the divisors of this integer. So that's the idea of the factoring method. And we'll be discussing the factoring method in this session. There's also inequality. We can use inequalities. So for example, sometimes we can prove that m is less than, for example, 6. And we are solving it on natural numbers. So we have just m equals 0, 1, 2, 3, 4, 5, and 6. So sometimes we use inequalities, sometimes we use factoring methods, and of course there are other methods as well. So we'll be discussing the factoring methods in this session. So let's start. Okay. So let's discuss factoring method. Okay. So first of all, I'll assume that you know the basics, the basic factoring identities. For example, x squared minus y squared equals x minus y times x plus 1. And I'll start discussing an important trick. I think it's called the Simon-Favorite factoring trick. But whatever, let's see what is this trick. So we are given this Diophantine equation. Solve m times n plus n equals 5. Of course, we have m and n are integers. So we have this m times n plus n equals 5. So how can we solve this equation? So here is the idea. We will factorize the left-hand side, and on the right-hand side, as we mentioned, we'll have just an integer. So the idea is simple. Imagine that we have factored this the left-hand side. So we'll have it written as multiplication of 2 expressions equals some integer. So here we should have m, right? And here we should have n. So now we have m times n. Okay, so now how can we get plus n? We should have here plus 1, right? So we will have m times n plus m. And also, how can we get plus n? Also, we will add 1. So now we have m times n plus m plus n. Okay, so now we have m times n plus m plus m. Of course, we have plus 1. But this is 5. This is 5. So we have this equals to 6. So now we have factorized the left-hand side. We have simply m plus 1 times m plus 1 equals 6. So now we can discuss just the divisors of 6. So we can write m plus 1 equals 1, 2, 3, and 6. Okay, but I want to mention something very important, that we are told to solve it on integers, right? So we should also discuss the negative divisors of 6. So if we set just this, we'll lose some marks because we have other solutions: -1, -2, -3, and -6. So we should always remember the negative divisors as well. Okay, so simply we will have m equals 0, 1, 2, 5. Actually, we just subtract 1 from this set, and we do the same for m, and we're done. So we'll get some list of pairs of the solutions. So this is the idea. Here we just factorize this by imagining that we have factorized it and then guessing what should we write here. That's the idea. So let's take another example. Let's take case where here we have negative. How can we factorize now this? We have -m equals 5. Well, the idea is the same. We just write two expressions equals some integer. Here we have m, and here we have m. What should we write here in order to get -m? -1. What should we write here in order to get -m? -1. And the same, we get this equals 5 plus 1 is 6. And we do the same. We just discussed the divisor of 6. So that's the idea. Okay. Now we will take a more generalized version. What about this? Solve the following equation: m times n plus 3m plus 7n equals, for example, 16. Now, how can we factorize this? Well, let's apply the same method, the same approach. We need to factorize this, so we write two expressions. Here we have m, here we have n. How can we get plus 3 times m? We just write here plus 3, right? So we get plus 3 times m. And here we write plus 7. So we get plus 7 times m. So this equals this, it's 16, plus 7 times 3, which is 21. And then we discuss the divisors of this, just as we mentioned. And we don't forget the negative divisors because we're solving it on integers. Okay. So that's the trick, basically. Now let's take an example. Okay, just a second. Okay, so we'll solve the following equation. Solve 1 over x plus 1 over y equals 1 over p times 2. But we're given that p and q primes and x and y are integers. So we need to solve the following: 1 divided by x plus 1 divided by y equals 1 divided by p times q, and p and q are primes, and we'll solve it on integers. So I'll give you 1 minute, try it yourself, and then we'll solve it. Okay, so try this. Okay, so let's start solving this question. Okay, so what we'll do at first is very clear. We'll multiply by p times q times x times y to get rid of the denominator. So we'll get the following. X times y equals p times q times x plus 1. Okay, so we'll do the same as we did earlier, because this is equivalent to x times y minus p times q times x minus p times q times y equals 0. Okay, so now we'll factorize the left-hand side, just as we did earlier. We'll write this two brackets equals sum here. Here we should have an x, and here we should have an y. X, y. So how can we get minus p times q times x? We need minus pq, right? And the same here. We need minus pq. So now this equals 0 plus p squared times q squared. So our equation now is x minus pq times y minus pq equals p squared q squared. So now we just discussed the divisors of p squared q squared. Since they are primes, we know what are the divisors of this. So we have x minus p times q equals 1. P and q are divisors. Then p squared, q squared, p times q. Then p squared q and q squared p. And at last we have p squared q squared. Okay, but what about the negative? What about the negative divisors? Do we need to discuss them? Well, actually, no, we don't need. Although we have x and y are integers, we don't need to discuss the negative divisors. But why? Well, take a look here at our equation. Since we have 1 over x plus 1 over y equals 1 over pq, so we can write the following inequality. 1 over pq is greater than 1 over x, right? Because it's 1 over x plus some positive number. So we should have x greater than PQ, which means that x minus PQ is greater than 0. So x minus PQ is greater than 0. So we don't need to discuss the negative divisors. So we just discuss these and get the solution. Okay. In order to check whether we did not forget any divisor, we can use the following identity, which tells us the number of divisors of a certain number. So given some number n, we can write it in the prime factorization as n equals p1 to the power of alpha 1, p2 alpha 2, pk alpha k. Then the number of divisors is alpha 1 plus 1 times alpha 2 plus 1, and we go on plus 1. That's the number of divisors. So here, since we have 3 squared, we have 3 times 3, which is 9. So let's count these: 1, 2, 3, 4, 5, 6, 7, 8, 9. So we did not forget any divisor. Okay, so we have solved this problem. Okay. So far, we have factorized the quantity when we have x times y. What about when we have some number multiplied by x times y? So, for example, this. Let's solve 3 times x times y plus 5x plus 7y equals 4, where x and y are equal. So how can we factorize this quantity? If we did as earlier, we'll write the following. Here we'll write an x, here we write a y. But the problem here, we have 3 times x times y. So what do we need to do? You might tell me, for example, write 3 here. Okay, but the problem is when we multiply, we have 3 times x times y, so that's good. But what about 5 times x? How can we get 5 times x? Whatever we write here, it will be some number, some integer, multiplied by 3 multiplied by x. And we can't get this 5. So what will we do? So we'll do some magical trick, very simple trick, which is multiply both sides by what? By 3. Multiply the left-hand side and the right-hand side by 3. So we will get 9 times xy plus 15x plus 21y equals 12. Now we can factorize this. Since we have 9 times x times y, we have 3 times x, 3 times y. And here, what we need right here to get 15? 5, right? 3 times 5 is 15. What should we write here? Since we have 21, we write 7. So now we have this equals 12 plus 35. Okay, and now we write this number and discuss the divisors and just solve it as we did earlier. So the trick here is just multiply by the coefficient of x times y. So if we have here a, we multiply by this a, and then we can factorize it by writing a times x and a times y, and everything is, since we multiply by a, here, this will be divisible by a, and this as well. So that's the trick. Okay. So we've discussed this very useful trick. Okay, but of course, it's not the only trick we use to factorize. Sometimes we just need to do something smart, so we don't have this obvious thing to do. So let's take another problem. Okay. So don't think it's geometry, but we have some right triangle. Okay. And here we have A, B, and C. And we have A, B, and C are integers. Both are integers. And we have the area of ABC equals the perimeter of ABC. So we have, let's name C. Okay, so find all right triangles where the length of sides are integers, and we have the area of the triangle is the same as the perimeter of the triangle. So I'll give you 2 minutes, try to solve this problem, and then we'll discuss the solution. Okay, so we'll start solving this problem. So the first thing you should do when you find this kind of problems, of course, it's not geometry problem, it's a number theory. So you immediately get rid of, for example, why it's a right triangle. Well, it's very clear that satisfies the famous identity c squared equals a squared plus b squared. That's all what we need from this right triangle. Okay, so we have c squared equals a squared plus b squared. What about the second condition? We have the area of ABC is equal to the perimeter of ABC. So what does that mean? Okay, So the area of ABC is simply A times B over 2, right? That's the area. And the perimeter is A plus B plus C. Okay, so let's multiply by 2. So we have A times B equals 2 times A plus 2 times B plus 2 times C. Since we have C squared equals A squared plus B squared, so we can get rid of this C. How can we do this? First of all, we need to isolate this C and then square the left-hand side and the right-hand side. So let's write 2 times C equals A B minus 2 times A plus B, right? It's the same as this equation. Now we will square both sides, the left-hand side and the right-hand side, and substitute C squared with A squared plus B squared. Okay, so now we will get 4 times C squared equals AB minus 2 times A plus B, and that's squared. Okay, so we'll substitute C squared with A squared plus B squared. So let's erase this. For C squared. So now we have simply 4 times A squared plus B squared equals AB minus 2 times A plus B, that is squared. Okay, so now we have just an equation with the variables A and B. We have got rid of this C. Okay, so let's expand the right-hand side. So that's the same as 4 times A squared plus B squared equals AB squared plus 4 times A plus B squared, right? Minus 2 times 2, 4 times AB times A plus B. Okay, now notice that here we have 4 times A squared plus B squared. So we will have 4 times, and here we have 4 times A squared plus B squared. So we can cancel this on the 2 sides. So now we have, let's take this here, 4 times AB times A plus B equals AB squared plus 2 times AB. So we have A times AB. So now we have this simple equation. Of course, we have AB in everywhere, so we can divide by this AB. Simplify. And of course, we have A and B are greater than 0 because they are length. So we have 4 times A plus B equals AB plus A. Okay, so now you should be able to solve this because it's the same as the trick that we have discussed earlier. So that's very simple. We have AB minus 4A minus 4B equals minus 8. So we can factorize the left-hand side. We have AB minus 4 and minus 4 equals minus 8 plus 16, which is 8. Okay, so now we have A minus 4 simply equals to the divisors of 8, which are 1, 2, 4, 8, and minus 2, minus 1, minus 2, minus 4, and minus 8. So we can simply discuss these cases and find what are the length of our right triangle. Okay. Actually, we can ignore the case when we don't need to discuss the negative divisors of 8, because if we have A minus 4 equals minus 1, then we will have B minus 4 equals minus 8, which means that B is minus 4. And the same for the rest. So we just need to discuss the positive divisors, and we'll get the solution simply. And we are done. So to solve this problem. Okay, so now we'll discuss two other problems, not based on our factoring trick, which are the following. So the first problem is solve x squared plus y times x plus y squared equals x minus y cubed. Okay, and we have x and y are non-zero integers. Okay, so we need to solve this. X squared plus y times x plus y squared equals x minus y cubed. And we have x and y are non-zero integers. Okay, so I want you to try this. I'll give you 2 minutes. And it's not necessary to factorize immediately. Sometimes we will factorize, but at the end of the problem. So just try expanding these, and then we'll discuss. Okay, I'll give you 2 minutes.
Swamp. Hello, sir.
So we'll start discussing the problem. First of all, when we see this kind of expressions, of course, we need to expand the left-hand side and the right-hand side. So let's expand the left-hand side. So we'll have left-hand side is x cubed plus y cubed plus x squared times y squared plus x times y. What about the right-hand side? Okay, that's a famous identity. So it's x cubed minus 3 times x squared times y plus 3 times x times y squared minus y cubed. Okay, so can we cancel anything? Yes, we can cancel this x cubed and this x cubed. And here we have y cubed and here we have minus y cubed. So we can move this to the left-hand side as well. So now let's try our equation. So we have 2y cubed plus x squared y squared plus xy plus, here we have negative, so we can move it to the left-hand side, plus 3x squared y equals 3x y squared. And also notice that we have y, and y. So we have y in each expression. So we can divide by this one. Since we have y is non-zero integer, so we can divide by 1. Okay, so we'll get the following: 2 times y squared plus x squared times y plus x equals, plus 3 times x squared equals 3xy. Okay, so that's our new equation. Okay, so what can we do right now? You might think we should factorize this like we did earlier, but it's not always necessary. Sometimes we can't factorize. Actually, we have a similar idea factoring, which is just look at the powers of x and y. Here we have 2, right? Here we have power of y is 1 and the power of x is 2. Where we have 1, 1, 1, and 1. So actually, we can discuss this as a quadratic equation using x or using y. But what do you think we should use? We use x or y? Which one is simpler? I prefer to discuss it using y. Because we have the coefficient of y squared is 2. If we discuss using x, we'll get the coefficient of x squared equals y. And usually we would like to discuss the simpler version, which is when the coefficient of y squared is 2. Okay, so let's discuss this as an quadratic equation. So we will write y squared here plus y plus something. Okay, so the coefficient of y squared is 2. What is the coefficient of y? X squared minus 3 times x. X squared minus 3 times x. Plus 3 times x squared plus x equals 0. Okay, so now we have written our equation as a quadratic equation with respect to y. So what can we do now? Well, there's a famous theorem, and the proof is very simple. When you have, or when you are solving the Diophantine equation, and you have a quadratic equation, then the delta must be, the determinant must be a perfect square. Well, the proof is very simple. Since we have solutions are minus b plus minus the square root of delta over 2 times a. And the solutions are integers, right? So we must have delta as a perfect square. So, well, let's evaluate our delta and solve it or find the values for x when the delta is perfect square. Okay, so let's erase everything and evaluate delta. Okay, so what is the value of delta? B squared is x minus 3 times x squared minus 4 times 8 times 3 x squared plus x. So that's delta. Now delta is x 4 minus 6x cubed plus 9x squared minus 24 x squared minus 8 times x. Okay, here we have minus 9, here we have minus 24. So delta equals x to the 4 minus 6x cubed. 9 minus plus 9 minus 24 is minus 15 x squared minus 8 times x. So that is delta, and delta must be a perfect square. So it must be equal to some m squared, where m is an integer, of course. So now we should start, or we should try to factorize the left-hand side. So let's try to factorize this quantity. So of course we have here x. Take x as a common factor. So we have delta equals x times x cubed minus 6x squared minus 15x minus 18. Let's raise this. Okay, so now we have x cubed. So can we factorize it even more? Well, how can we factorize? Usually, try finding some roots. So can we find a small root? Usually we try 0, 1. So can we try 1 here? Well, we can't, because here we have 1, here minus 6, minus 15, minus 8. So it can't be 0. What about minus 1? We try minus 1. We have minus 1. And here we have minus 1, so we have 16, 16 minus 8, minus 6. So 8. Okay, let's try this. I think we've made some mistake. Minus 1. And okay, sorry, here we have minus 1. And here we have plus 15. So we must have this minus 14. And minus 8 minus 6 is 14. Okay, so minus 1 is a root of this quantity. So delta must be x times x plus 1 times x squared x and something right here. So let's try to guess what are the coefficients of x squared x and what do we have here. So I'll give you 1 minute to try to factorize this, and don't think we will factorize it as x squared. We can even factorize this x squared. So I'll give you 1 minute, and I want you to factorize this as a multiplication of 4 expressions. Okay, so try it. Okay, so here we have x times x plus 1. So what should we have here? Well, first of all, since we have x cubed, we should have this as 1. So we have just x squared. And what about this here? Since we have minus 8, here we have minus 1. We must have minus 8, right? Minus 8. What about this one right here? So let's take a look at the functions of x squared. Here we have it minus 6, and here we have it x squared 1.
Sorry, I
plus
didn't get you. Can you repeat it again?
do we need to write here to get minus 6? It's very clear. It's minus 7. So now we have plus 1 minus 7 equals minus 6. Okay, so we have
Can you
factorized
repeat
it
that again?
as a multiplication of three expressions. But can we factorize this? Well, yes, we can. Note that minus 1 is also a root of this expression. So we can also write delta equals x times x plus 1 times x plus 1 times, of course, here we would have x, and here we have x minus 8. So that's delta, and of course it's equal to x plus 1 squared times x minus 8. So this expression, this quantity, must be equal to a perfect square. So should be equal to m squared. Okay, but since x plus 1 squared is already a perfect square, so we must have x times x minus 8 is a perfect square. So now we will erase everything and search for the values of x such that x times x minus 8 is a perfect square. So we must have x times x minus 8 is m squared. Of course, it's not the same m, but it must be a perfect square. So how can we find the values of x such that x times x minus 8 is a perfect square? Well, if you know the properties of the GCD, or the greatest common divisor, then it's very simple. We can discuss it using the GCD, but we'll provide a solution using just factoring. Okay, so how can we factor this? Well, the idea is very simple. We will complete to a perfect square. Since we have here, the left-hand side is x squared minus 8 times x. What should we add to both sides to get a perfect square to the left-hand side? We need to add plus 4 squared, right? We need to add 16. So we will have this m squared plus 16. Now this is x minus 4 squared equals m squared plus 16. Okay, but why? What do we gain? We factorize the left-hand side. Well, now we have perfect square and a perfect square, and we have an integer right here. So we can move this to the left-hand side and factorize it. So we have x minus 4 minus m times x minus 4 plus m equals 16. Okay, so now that is very simple. We just discussed the divisors of 16 and we get our solutions. Since we will have here x minus n, the value of x minus n, and here the value of x plus n, so we can find the value of x, and we will be done. Okay, let me write the solutions. We will get x equals minus 1, 8, and 9. It's very simple to discuss these cases. Okay.
Can you repeat that again?
So we will discuss now one last problem. Write this Diophantine equation. Solve x squared plus 6 times 6 times x times y plus 8 y squared plus 3 times x plus 6 times y equals 2. And we have x and y are integers. Okay, so I'll give you 2 minutes to try to solve this problem using the factoring method. So try to factor the left-hand side and write it as a multiplication of some expressions equals an integer. Okay.
Can you repeat that? I didn't get you. Okay, let me ask you a question. What's x squared minus 2x plus xy plus 2y? Can you do that for me?
I think he cannot hear you right now. You can probably ask questions at the end.
Oh yeah, sure. There's a guy in this group. His name is Chris Me, and he told me to sing in this group. He sent me the username and password to talk something bad. So kick him out. So block him.
So let's discuss the solution. So first, we have x squared plus 6 times xy plus 8 y squared plus 3 times x plus 6 times y equals. So how can we factorize the left-hand side? Well, if we take a close look at x and y, we compare the coefficients of x and y with each other, we will realize that the coefficients of y is always stronger or greater than x. So it's very logical not to factorize this as these 3 quantities as x plus y squared, but to write x plus 2 times y. So let's try to factorize this by using x plus 2 times y. Because as we mentioned, here we have 6 compared to 3, here we have 8 compared to 1. So if we write here x plus 2 times y squared, so this x squared we don't have x squared anymore. Here we have 4y squared, so we have plus 4 times y squared, y squared, and here we have plus 4 times x times y, so we have plus 2 times x times y. And here we have plus 3 times x plus 6 times y equals 3. Okay, but can we get x plus 2 times y squared from this side? Well, yes, if we take 3 as a common factor, we have x plus 2 times y. Then what about this? Also, if we take 2 times y as a common factor, we get x plus 2 times 1. So we can factorize this using x plus 2 times 1. So let's try this. squared plus, we said 2 times y times x plus 2y plus 3 times x plus 2y equals 2. So we can take x plus 2y, it's a common factor. Now we have x plus 2 times y plus 2 times y. We have x plus 4y plus 3 equals 2. And we're done actually, because we just need to discuss the divisors of 2, which are, of course, the negative and the positive. Minus 1, minus 2, minus 1, 1, and 2. And we will get the solutions. And so we're done. Okay. So that's everything we will discuss in this session. We have learned the factoring method. And of course, I mentioned that there are other methods as well. There is the inequality method and the using of modulo. And there are other methods as well. But that's for this session. We have learned the trick that we discussed earlier, factorize quantities a times x plus a times x times y plus b times x plus c times y. And we have taken some other problems that use the factorizing method. Okay, so now we'll move to the questions section. Okay, can you hear me now?
Yeah, I can hear you.
Okay, so are there any questions?
No, I'm not here to ask you questions. There's a guy whose name is.
I can't hear you very well.
Does anybody have any questions? Please ask them if you have now.
Okay, so I write some books that I recommend for number theory in the chat section. Okay, so there is a book for Sato. Just a second. Okay, so that's the first book for Sato, number theory. And there is a book, a complete book for just discussing the Diophantine equations for Tito and Risco. Just a second, Diophantine equations for Tito and Risco. And there's also number theory, also for Tito and Risco. Those are the books that I studied when I was participating in Math-Olympiad for Tito, and I think there is another one. Okay, Doreen and Rika. Okay, that's basically the 3 books that I studied when preparing to Math-Olympiad. Okay, so are there any questions?
If you could read the names of the books aloud for the recording, it would be really helpful. Or I can do that. If you.
I can't hear you clearly. Can you write the question on the chat?
It's not a question. It was a request. Please, it's nothing. So the books you recommended were Naoki Sato, number theory.
Yes,
and then Diophantine equations for T2 and Rescue.
Yes.
And number theory for T2 and Dorin.
Yes.
Thank you very much.
Okay, welcome. So there are no questions?
So I think there are no more questions. Thank you very much for the session.
Okay, welcome. Thank you for inviting me.
Yeah, it was a wonderful session.
Thank you, sir.
Thank you.